the way I wrote the program. You have to have the data in the list first. My God, it's hot in here. It's getting ridiculous. Like, it was so nice when we first walked in, and now it's just getting ridiculous. And Eric still has his damn Carhartt jacket on, and his hoodie, his insulated jeans, and his boots. I shave my head right now. All right. Run the data L1, L2. I mean, pick on your hair. It's awesome. I give you mad props.
Don't worry about it.
4, 6, 7, 3.
I'm cozy, so I don't care what you.
That's okay. I don't care what you think. I'm nice and comfy. 5, 5, 5, and 5. Just so you know, heads up, this is one of those tests, you have to run it with enough data. Chances are we don't have anywhere near enough data. Actually, we know we don't. Because in order for us to have enough data, we'd have to multiply a quarter by our sample size and make sure each one was at least 5, which we end up getting. And we have, oh no, we have exactly enough data. 20 times a quarter is exactly 5. This is the smallest possible data set we could have run a golf on. Hot damn, we got it. We actually got it. Good, 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 good. All right, so let's run it. Program golf. Okay, it's going to ask you where your observations are in L1. Expecteds in L2. Run it, see what it tells you. Are we roughly spread through the year? Or is there any, let me ask it a different way, because this is the way I'll ask it on the, does it appear we are not spread equally throughout the year? Now, that sounds like a stupid way, but that keeps it in line with the appears, does not appears. Now the answer to my first question probably was easier to tolerate. But the answer to the second question is how we've asked, does anything appear to have changed from the null hypothesis? Let's ask it that way. No, it does not appear anything's changed from the null hypothesis because the p-value is huge. It's bigger than 5%. It's 57%. That means we believe the null hypothesis. The null hypothesis says that everything's spread throughout the year evenly. But the way we've been phrasing it is, you've been circling does not appear with big p-values, so I'll have to phrase that to circle that. So it does not appear that we're not uniformly distributed. Does that make sense? It's a double negative, yeah? It does not appear that we're not uniformly distributed, but double negatives cancel and it insinuates the positive of it appears we are. Kaylee, ask me that question.
But we're circling does not appear because it's a large.
Because I'm trying to train you guys to realize, and this is where I get lost in, do I make them circle something or do I make them write it? Because if you wrote it, you could write it 2 different ways. It appears everything's uniform or it doesn't appear it's not uniform. It actually makes a more logical sense that it appears that everything's uniform. But that goes against what you've been circling all term, yeah? So I'm going to keep it with that language. The double negative language will probably show up here. That's okay though. Yeah?
But we are saying that it is evenly distributed.
It doesn't, yeah, because it doesn't look like it's not.
Okay.
So it is. Yeah.
So with a large p-value,
Yep.
we are seeing even distributed.
Right. Large p-value means you believe the null. And the null looks like it's an evenly distributed data set. Yeah. There we go. Our zodiac signs are all spread out evenly-ish. But maybe not. I don't know. We didn't test that, did we? Yes?
On the quiz, you stated to make sure that it has the correct variable.
Yes!
What did you mean by that?
Chi-square.
That's all?
Yeah, that's why I coded the program to have that with you. So you're going to have 3 different variables on this exam. You're going to have 2 chi-squares for the GOFs. So you'll just put chi-square equals.
Right. Okay.
What's the, if you're testing 2 means, what is the variable you're going to have? Be brave. That's the parameter you're testing. What's the test statistic variable? You've mentioned it a bunch of times today. T. The t-test. So you're going to have t equals. And if you're testing 2 proportions, it's going to be z. So there you go. Each of the tests has its own variable. Z-test for proportions, t-test for means, and chi-square for GOF, which is actually proportions too, but it's more than 2 of them. What's that? No, Michael, go ahead. Are you sure?
Let's just call it x squared.
Let's just, you can call it x squared, it's fine. I got no problem with that.
You said the proportions was the z-test?
Yeah, for 2 proportions, z-test. Yep. 2 prop z. 2 prop z. Cool? There you go. Don't have to cram anything else in there. It's kind of silly. Like I said, if you can understand what a p-value is, I'm totally stoked. I'm totally stoked. Honestly, walking out of this class, if you can walk into your next class and know foolproofly what a p-value is, and one of the reasons on your out of class I make you fix that one question online, Pam Purdue, you're answering the question wrong. P-value's chance null hypothesis being correct. False! Ding! Thanks for playing. Your job, fix her response. Put a correct response in there. And it's amazing, if you Google what is a p-value, in threads, in statistics threads, discussion threads, a bunch of them are wrong. People do not understand what a p-value is. You guys do. Your job is to go tell me how to correct Pam's answer. Whoever the hell Pam is. Cool? That's it. Go back out of a -4-degree day. We'll see you on Thursday, yeah?
Oh, it's 5 degrees now.
5 degrees now. 5 degrees now.
Oh, mine.
What's that, Jack?
Mine says.
Oh, yeah, we can probably fix this without